And our next speaker is Nikola Tanjga, here to tell us about building an open source FML compiler.
Thank you, Tim. So please just call me Nick. Who am I? I'm a research engineer at the Austrian Institute of Technology. That's a company that is focusing right now in multiple research projects on the secondary use part. And I'm also a standards engineer at the ELGA GmbH. That's kind of like the primary use national EHR in Austria. So working in both companies. And we had a problem like a few years ago where we've seen what the development will be with the EHDS. We ourselves in Austria, that's our Austrian border, have an XDS infrastructure with multiple domains having their CDAs there. We also do have an e-medication central application built kind of like connected to the XDS part. And these are all HS7 CDAs, having them for more than 15 years, I think, right now. Having over 30 million CDAs, laboratory reports, hospital discharge summaries, and having lot of medication data. Beside of that, we also have the vaccination data since Corona there. Beside of that, we will build an application for the Austrian patient summary. That's kind of like the international patient summary, added a few constraints so that we can use our Austrian social security number and so on. This will be on FHIR, and these Austrian patient summary will be filled by all the data we already collected the last 15 years of a patient. Beside of that, there is a challenge that the EHDS regulation states, the 2029, there will be the patient summary and e-prescription e-dispensation NCPs that should then work and connect all these data, but they will come as an HS7 CDA. We already decided that our patient summary will be FHIR. And then the fascinating thing, a few years after, I think 2031, there will come the laboratory report as a FHIR bundle, and also the hospital discharge report and the imaging report. We do have this free already as CDA. So we have to map somehow from CDA to FHIR, or from FHIR to CDA in our patient summary context. So there are many methods to exist to map data from one semi-structured data format to another. I think we have in DevDays like 3 or 4 talks just about mapping data from one to another. And the most efficient solution still is today efficient, that you directly code the rules. But this can only be changed by someone who has the knowledge of the mapping content, the mapping rules, and the mapping technology at the same time. So it's not efficient over time. Beside of that, HS7 FHIR saw the problem multiple years ago, and they made resources for mapping purposes. Does anyone have ever heard about structure map, concept map, or FHIR mapping language? Good. Half of the people did not. So these are resources like structure map for the transformation of one structure definition to another structure definition. You can transform the elements, state the rules there, do groups, and it's really fully thought through. There is some things we still have to fix, and for the R6 release, this will be normative. The structure map, as also the concept map, that's the same thing just for the terminology part, so that one concept can be translated in that case, to another concept. And beside of that, they thought like, okay, we should do something more human readable, because this is a resource. Humans don't like to read resources and see, okay, that's my rule how to map one element to another. It's really hard to understand. So they made a FHIR mapping language, the FML, for creating structure maps and simple concept maps. There are already tools who work like interpreters, who take the FHIR mapping language, interpret it at first to convert it to structure maps and concept maps, and then do an interpretation step and transform and translate. Transform is the part of the structure map, translate is the part of the concept map, the input to the desired output. Unfortunately, we looked at these tools, and they are way too slow for our process that we want to have, that the transformation is happening synchronously. So we do have a CDA, his hospital discharge, and at the moment we see, okay, he's demanding it as a FHIR, and it should happen synchronously, and that's with multiple seconds of a transformation, not good. So right now there is the gold standard, it's the happy project you do know with a Swiss extension called Matchbox that is working the fully tool set, so everything's working, it just takes a time. So we discussed this problem since mid-21, and we formed a working group in Austria, the CDA to FHIR working group, and we wanted to solve this technical problem. We thought about, okay, it's an interpreter. It's always reading all the rules and afterwards doing the transformation. So why not read all the rules, because I'm not changing the mappings the whole time, having something like in a compiled way, and then just use that compiled thing. It would be at least double as fast, quicker, way quicker. So in this working group, there were multiple companies, and two of them made a partnership. That's the Austrian Institute of Technology, focusing on secondary use. Saw the opportunity, okay, such a compiler or such a quicker way to transform data could also be used for multiple steps in pseudonymization, in transforming to maybe something like OMOP, CDA to OMOP, or FHIR to OMOP. And the Elga GmbH that needed the whole thing for the EHDS coming up. So we used the MVP concept, like the minimum viable product concept, where we did with build, measure, learn steps, as quick as possible, a first version, where we tried to split up this interpretation part. And let's get into the current approach again once more. You have normally, like if you don't have FHIR resources, you have to create for the whole mapping approach these logical models. So a logical model for all the structure definition that's out there, and you have to do, for the CDA schema, structure definitions that do exist in some IGs, but you have to adapt them again for your national extensions that you already built in. So you have extra a logical model in structure definition form, put that into the mapping engine. Beside of that, you have your map that somebody wrote. Normally, this is really done with experts who say, like medical experts who are saying, yeah, this is an element that states in the other standard something like this, but it matches up, so we will take that. Also, the FHIR mapping language can be put into an IG, so the FHIR mapping language elements can be balloted themselves. So we plan in Austria to ballot our mappings officially, and we do have many friendly users who are experts in their medicinal area or health area, and can also give feedback if this is really something they could also see, these mappings we provide. These two things you can put into one mapping engine, and then this interpretation happens every time when we get a CDA into and want a FHIR out, or also the other way around. If you get a FHIR, the mappings are not bidirectional. You have to write extra mappings for the other way around. You learn from the first one, but it's not a good thing to just reverse them. And then you have the mapping engine interprets again and going out to the CDA. So our approach was we built something, the mapping language compiler for health data. We call it MaLaC-HD. And at first, we didn't like the whole structure definition thing for CDA or for future models. I don't want to build a structure definition for OMOP if I want to map there. So we thought about, okay, there are tools who can convert XSD, an XML schema, to a Python library, just to serialize the data or deserialize the data. It's really easy to do that. Beside of that, with some classes we make dependencies on, you can easily add own classes like OMOP and so on to have then there a serialization or deserialization step for OMOP data. So adding the FML to MaLaC-HD, together, it just generates one Python module that can be reused. So we don't have this whole interpretation step, we just have a compile, and after the compile, we can use this Python module. These are completely independent, having their dependencies taken with them. And what's the comparison? We do have like the FHIR server with the Matchbox extension and MaLaC. Both are still using the FHIR mapping language. And beside that, we have the CDA, logical model, structure map resources, and the FHIR server that you have to have at that time of the transformation. We just have to use our Python modules. The conversion time for our typical ELGA CDAs are 3 to 5 seconds. And I'm really sorry, we had this presentation also at the VGM there. I stated it's 5 to 10 seconds. We didn't use the newest version. There were many fixes there. So it's 3 to 5 seconds. And we are about 30 times now quicker with our way to compile the whole thing first. If you want to use them, you can do it by pip, install MaLaC-HD. If you want to change a bit of the codes, you can do a clone and afterwards a pip install -e. If you want to get the source code or maybe just mark the project, this is a link to the GitLab. You can do the steps like the translation to a library, like you have a finished Python library. In 2 steps, you can also do that whole thing in 1 step if you want to transform directly, but this will translate the FML to Python. You give it a map, and you say the convert output is that. There is then your Python library, and if you want to do the transformation, you just put your input there, like the source, and then the target, and that's it. If your mapping works on Happy, it also works, or on the Matchbox, it also works with MaLaC-HD. The whole thing is open source and LGPL licensed, so you can reuse it. And if you want to have it just uses a library, that's what LGPL is primary for, you could just import it in your existing Python app. The finished transformation rules as one Python library. So you can reach me under different addresses. Like for secondary use, please write on my AIT address. For the primary use, things more on the ELGA address. And if you need an appointment for something else, please write me on my office address. And thank you very much for listening. Getting to the Q&A.
Questions?
Yeah, thank you for the talk. Just curious, what made you want to pick Python for compiling the modules for this like meta compiler?
Again, I'm sorry.
Yeah, what made you want to pick Python? Because you're like this is a cool like meta compiler. So you had maybe a couple of different choices for what you could have converted the FML into.
So the question is?
Oh yeah, so the question is why Python?
Why Python?
Yeah.
That's a good one. Thank you for stating that, sorry. We are right now working to also have our output as a JavaScript, because we had a project where we had to use the compiled Python library that is having all the mappings in the browser. So there are some projects like Pyodate where you can use Python in a browser kind of easily, but still it's not that performant. So we had the idea we should do it in JavaScript so that you can do, if you do the mapping like in the browser, it's everything client-sided. You don't have to have a server application doing that. Thank you for the question.
I mean, seeing that it's Michael's hand up, I was going to ask.
I do.
It's probably the same, similar vein. What do you do for non-deterministic mappings, for like concepts that you have one value and in your target you have two values? Are you just discriminating prior to loading everything in, or are there configuration options or things like that?
Like if you load multiple structure, like multiple FMLs, linking, importing, and then having.
So in the concept maps for value sets, I use the example of, just because it's easy, in R4, encounter.status, one of them is finished, and R5, there are discharged and completed. And both are mapped from finished, but the concept map just tells you, yes, you have finished, you could have discharged, you could have completed. And so when you actually implement the translation, though, do you just pick first?
Yeah.
Yeah.
Right
Okay.
now, it's that. We
Yes.
just pick the first. We do give a warning in the console, but I think we copied that approach. Someone else is also doing it. I think it's Happy. It's also taking just the first. So we looked at the source code and, hey, they're taking the first. We'll do the same thing. Yeah, we don't have a better solution right now. But yeah, there are many such cases. I know what you mean. Thanks for the question. There was...
Any other questions? Might as well.
So I do have another one that's a little deeper in FML. A lot of the structure maps in some contexts, and I don't know which ones you have for this, how they work, but are optimistic on some of the mappings when you talk about like type conversions from something that's broader into something that's narrower. Do you just throw warnings in those cases, or have you tested those types of things? Like if you're moving from a string to an ID, the string might be longer than an ID, but the FML just says, yeah, you can map strings to IDs. And then you have to pick if you're truncating or throwing or warning or... have you run into those scenarios?
We did, and that's the reason, because of the scenarios, we do a best guess there in the code, but that's the reason why we will have validation steps before for the input and also for the output. And the problem with validation is also the time, because we want a synchronous thing. So teaser, maybe in 2 years at the DevDays, I'll come with a new validation tool where we try a similar approach or something like that. Yeah. Cool. Thanks.
One more question. Okay. Thanks, Nick.
Thanks, guys. Thanks for listening.